All right. So the lattice model, you're gonna make the grid like if you have 2 digit by 2 digit, you're gonna make 2 by 2. If it's 3 by 2, you can make 3 by 2 grids. Okay, and then you're gonna break each of the grid into halves. So two triangles using diagonals in that direction. Okay, so if you're looking at this square only, we have two parts. Upper part, we're going to have 10 digits. Lower part, we're going to have 1 digit. So 5 times 7, 7 times 5, 35. So you write 3 here, 5 here. That's what it is here, okay? For this one, this is the intersection part of 3 and 5. So you need to think about what is 3 times 5. It's 15. So write 1, 10 above and 5 below. Do the same thing for the rest of it. Okay? Then you can add those digits together. So here, starting from the bottom one here, 1 digit, you add all this together and you get 17. So that 10, you're gonna carry that over to the next digit. So you have 10 there, so put 0 and carry over that another 10 and put 2 there. Does it kind of make sense? Okay, so let's practice that one more time. We are increasing the digits into 3 digits. 948 times 827. So I want you guys to write this on your notebook, make 3 by 3 grids. And what's next? You need to make the diagonals, right? So go this direction, this direction. Let's see if I have it. Yeah, this direction. You can extend it. You can extend at the bottom here so you can see what this goes in each. And then fill up the grids. Okay, I will next do that. 948 times 827. I will walk around and see how you are doing. Sorry to say this again, but please have build up the habit of cleaning your area before you use it for your health. Okay? We still need vaccination, so before that we have to continuously work on, taking care of ourselves and others. So I will say this again and again. Please let me know if you need help, okay? The order doesn't matter in this case. If you want to start from here, you can go to here. You can go up, it doesn't matter. So in this way, you can do 8 times 8 is 64. And also put 6 above and here. How about this one? There we go. Yeah, keep on doing that. You have 2 and 8. What's the answer? Find from you. 777. Yeah, whatever that is. Yeah. Very good. I was making sure. Yes. Awesome. I didn't check everything. If you did it correctly, it should be right. So I don't know if it's right. Okay, this process is okay. Okay, so let's do this together. Let me try to use this. Okay. Did everybody got the answer? Yeah? Okay, so let's do this together. You need to help me out. So we have 941, 8 times 827. Thank you. So you can write from 9, 4, 8, 9, 4, 8, 1, 8, 2, 7. When you're writing this down, it is easy for you to start from top left and go around this way. Okay, so you have 3 by 3 grids. Sorry, mine is really ugly. And make sure you draw the diagonals this way. This way. And it's really ugly, but it doesn't matter. Okay, so let's build up each of the grid. 8 times 8, 64. It doesn't matter where you start from. I can start from here. 4 times 2, it's 8. So there's no tens digit, there's 8. Right? How about here? 9 times 8, 72. 4 times 8, 32. How about here? 9 times 2, 18. How about here? 8 times 2, 16. 9 times 7, 4 times 7, 8 times 7. Thank you. Now what can we do? We can just add them together, right? So one's digit. What is one's digit? 6. So this is the answer. One's digit is 6. How about here? 6 and 5 is 11. 11 plus 8 is 19. So put just 9 there and carry over one's digit. Right? And you have these together, it's 10. That's 10. And I have 6 together and 3, so it's another 19. So you can carry over another one there. And I see 2 and 8 together, those are 10, right? 10 and 7 and 6, 23. So carry over 23. And you have 5, 6, 7, 8. And you have just 7. If your answer is different from mine, maybe your multiplication fact went wrong, or maybe your carrying went wrong, right? So this is the answer. How do you write this? There we go. Because this is the ones digit, right? And this is the biggest digit. So we can start from here and just write it down. Okay, how do you feel about this lattice model? Is it good? Okay, we can always extend, the digits. So let's do one more practice and we're gonna move on. How about 4 digits by 2 digits? So I'm gonna go something like this, times 73. 3,491 times 73. Make the grid. You're gonna have 4 by 2, right? And then you can make the diagonals. If you are done, I want you to compare your answer here with standard algorithm. Good, nice. Is that Andy, show me your work? Okay, thank you, Andy. Alisa? Okay, thank you. Okay, awesome. I think most of you are done with the lattice model. Okay, so I want to go really, really fast here. 1 times 7, 7, so 0, 7. 7 times 9, 3, 3, 39, 27, 34, 33, 9. Let's add them together. So we have 3, 7 and 7, 14. And we have 4, 5, 6, 7, 8. And here 9, oh sorry, what is it? 9 and 1 together is 10, right? And that's 14, so 24, thank you. And you can add 4, 5, and 2. Did you get this? 254,843. Awesome. And let's compare that with our standard algorithm. I really, I know you don't like this, right? Standard algorithm neither. I prefer to have partial products because standard algorithm is coming from partial product. I think it makes more sense to the students too. So let's go with the partial product. 3 times 1. But I'm going to mix with the partial product and standard algorithm there, okay? So what's 3 times 1? 3 times 9? 27. So can I write it here, 20? Because it's on this digit, right? That 2 is 200. 3 times 4? 12. So 10 and 2. I already have 2, but I have another 2 there, right? Because 3 times 4 is 12. So what is it? 2 and 2? That makes 4. Are you confused? No. Okay. 3 times 3? 9. 9 and 1 together? That's 10. Okay, so we are done with distributing 3. Now we need to work with 70, not 7. So we start from the 10th digit, right? So we need to put 0 there. 7 times 1? 7. 7 times 9? 63. So that 6 goes actually here. You don't have to think about this because we are done with multiplying everything by 3, right? So you can erase it and write the 60 there. Where am I?
7 times 4.
7 times 4, 28. So 2 goes here, but 8 plus 6 is 14. So I have another one here. 3 times 7, 21. Plus 3, 24. See, we are already confused. So when we are using this standard algorithm, I think it's a little more complicated. And you tend to make more mistakes. 7 plus 7, 14. So 5, 6, 7, 8. And we have 0 plus 4, 4. 1 plus 4, 5. And 2. So we get the same answer, but which one is easier? To be honest, this is easier for me. I don't know if you feel differently, but I think for younger students, this is a little bit easier model. Or we can even do the area model. So let me erase this and I'll draw the area model quickly. Okay, so to draw the area model, what can we do? We can do 3,000 plus, it doesn't matter if you know about the size, we can just approximately going smaller, 400 is smaller than 3,000. You just break that into the digits. So 9 is 90, and you have 1 there. So this part here, the width, do you call this as width and height, or length and width? Which is length? I don't know. Sometimes people say this is the length, this is width. Sometimes they say that around, the other way around. So actually, it doesn't matter because we can flip it over, right? But anyways, this part is then 70 and 3, right? Then you can find the area of the rectangle. So we can have this kind of rectangle. Are you following me? Are you with me? Okay, so 3,491 can be broken into 3,000 plus 490 and 1. And on the other side, 73. 70 the rectangle with their areas. So here it's 3,000 times 70. So we have how many zeros? 4 many zeros, right? Because this is thousands and that's tens. So you just count how many zeros there are. Then you can just multiply 3 by 7, 21,000. So when you're looking at this number here, 21, it's actually 21,000. And as you can see in the answer here, that 21,000 was here, right? And that's matching with this. 21,000 is in this before you added 40,000 there. So 21 is 21,000. Okay, so you can compare these values with this lattice model and you can see how they are connected. How about in this rectangle? We have 3 zeros, 1, 2, 3. You can just do 4 times 7, 28. It's exactly the same as this part. Okay, and here 7 times 70 times 90, 6,300. 1 times 70, 70. 1 goes here, 3,000 times 3, 9,000. 400 times 3, 400. 90 times 3, 270. 1 times 3, 3. Then you can add them all together. 210,000 plus 28,000. 6,370. When you're writing, make sure you line up with the digits. And you have 9,000, 1,200, and 270, and lastly 3. Then you can add them together. So in the ones digit, you have 3. In the tens digit, 7 and 7, 14. So move up 10, and carry that up. And where are we? Here. 1 and 3, 4, 5, 6, 7, 8. Nothing was carried. So you can see that's 10 and that's 14, so 24, 2, and you have 5 as the total, and you have 2. So this is actually same as the partial product, right? So I think either area model or lattice model is very helpful, but it's up to you. Maybe you feel differently. But I just want to show you there are a lot of different ways, and students conceptualize that differently. So you need to know their thinking process, and you also need to know a lot of different strategies as a teacher, right? Okay, and introduce them and let them choose what their preference is, whatever they like the most. They can choose that, specific strategy or the model. Okay. So Morgan, what's your favorite way of multiplying?
I like the box.
You like the box? Lattice model?
Yeah.
Okay. How about Alyssa?
Probably the lattice model.
Lattice model too. Is there anybody who prefer to use different one? Area model? Standard algorithm? Lattice model? I see some. Partial product? Okay, what other? Those who didn't raise a hand, what's your favorite model? Anna?
I like the lattice.
You like lattice model too? Madison?
Probably the lattice or the area.
Both of them?
Yeah.
Either one?
Yeah.
Okay. Anybody else? Jimmy? Okay, Tana? Lattice model. Alyssa Leach? What's your favorite? Alyssa, I'm talking to you. Alyssa, what's your favorite model to use? You need to unmute.
I mean, she should be able to hear you even if she's on mute.
I don't know. But Andy can hear me, right? Andy, what's your favorite model?
Yeah, I can't really hear. Are you talking to me or?
Yeah. Okay, Andy first.
I still like the standard model better. I like to do it the standard algorithm.
Awesome. Okay, understand?
Good.
That's okay. I think she has some statics in her Wi-Fi, I guess. All right. Anyways, yeah, you can get to see there are a lot of different models that you can use even when you're just doing the multiplication, right? Okay, now let's move to the mental computation. We did this in addition and subtraction too, right? So again, you don't have to remember the name, but just know there are different ways of estimating and mentally compute the multiplication. So front and multiplying. Am I sharing? Front and multiplying is you multiply the front first. So 6 is 60, right? So 60 times 5, and you can add that by 4 times 5. Okay, so that's the same as we are doing as partial product, right? When the numbers are easy, you can do this easily, but when numbers get complicated, it's not easy to use this kind of method, right? So another one that you can think about is using comparable numbers. So for example, you have many numbers like this, 2 times 9 times 5 times 20 times 5. How would you solve this easily without using your pencil or paper? Anyone? Haley?
I guess I haven't figured it out completely, but I would do 5 times 2 to get 10, and then 20 times 5 to get 100.
And what is left? Times 9.
Times 9.
So yeah, I like that idea. So I'm gonna do the same way. 2 times 5 is 10, and 20 times 5 is 100. So together, when you multiply 10 and 20, 100, you get 1,000. 1,000 times 9 is 9,000. So without calculating with a pencil and paper, we can do that mentally, right? So yeah, you combine the numbers differently by switching the numbers around. We call that a property? Commutative property. Awesome.
Commutative.
Yes, we use the commutative property, and you can combine those compatible numbers together. So yeah, we can easily find that's 9,000. Awesome, very good. Okay, and another way that we can think about is thinking with money. I don't think this will work for other countries because we have different numbers and money system here, right? So we know we have 25 quarters. Not many countries use that, 25 cents kind of, because they just use like 10 of something is next one and 10 of that is next coin, things like that. But we have nickels and we have quarters. So those are very helpful for us to understand better. Okay? So I think that's one good advantage for us. So for example, when you're doing 64 times 5, one way you can think about nickel is half of a dime. So think about times 10 instead of 5, because it's half of the nickel on the dime, right? So if you are doing times 10 instead, it's easier. We know it's going to be 640. But since nickel is half of it, just make it half. Then it's going to be 320, right? So you can think about that. 52. If you are thinking about $1 as 100 cents, 50 is half of that. So we get to know, oh, this is $64 if this is 100, but since it's a half, we have a half of that dollar, right? So $32. Does it make sense? No? Yes? No? Maybe to some of you it will work, but for some of you maybe not. Or you can just think about this as like times 100 is 6,400, but 50 is a half of 100. So just make it half, 3,200. Okay? How about this? You can think about this as a quarter, right? So if you have, well, you can think about how many quarters does that make? Well, since we know if we have, I don't know, if we have $1 instead of 25 cents, that's 100 cents, right? Then we have 6,400. But since we have only a quarter, that's 1/4 of it. So think about 1/4 of $64 or 6,400 cents. What's 1/4 of $64? Just divide that by 4. So you have $16 or 1,600 cents. Yeah. Okay. Especially that's helpful when we are doing the percentage and the fraction. Okay, like 25%, 75%, things like that. Okay. And think about estimation. Again, there are a lot of different ways. You don't need to remember the names, but you need to know how to do that. Okay. Front end. So similar to the mental math, you can just do 500 times 8 plus 20 times 8 plus 4 times 8. For a number like this, it's simple and you can easily find it. But when it gets complicated, you need to think about different strategy. And comparable numbers is another thing that you can do. Okay, so instead of you are multiplying 524 by 8, you can think about 525 because 525 is very close to 524. But 25 is easier for us because we have a quarter. And when you multiply 24 times 8, it's like 25 times 4 plus 25 times 4, right? 25 times 4 is like $1. So you have $2 there. And then you can think about 500 times 8. So $5 times 8. And you have 5 times 8 is 40. So $40. $40 plus $2, $42. You can think about that way. Does it make sense? Okay, so we are done with the multiplication and we're gonna move to division. Are we good? Any question for the multiplication so far? Is there any concept that you want me to go over? Or we're good? We're good? Okay. So again, when we are doing the addition, subtraction, multiplication, we use a lot of different models. And for division, we're gonna use a lot of different models too. So thinking back in multiplication, the first one we thought about was multiplication as repeated addition, right? In division, you can think about division problem as repeated subtraction. So for example, 18 divided by 6. How can we model that as repeated subtraction? Starting from 18, you can go backwards because it's a subtraction. Okay, you're gonna subtract 6, and you're gonna see how many 6 you can subtract. 1 time, 2 times, and 3 times, right? So you were able to subtract 6 3 times from 18. So we can write that as 18 divided by 6 is equal to 3 times. Okay, so you can use repeated subtraction models. If you think back to multiplication with repeated addition, what we did was 6 times 3 is equal to 18. Right? So you can see the relationship there. Okay, so number line is there. I'm not gonna do that because we all know that. Okay, so 18 divided by 6 can be modeled by repeated subtraction. And we know that 6 is subtracted 3 times to reach to the number 0. Okay, another model that we can think about is set model. Another name for that is partition model. So we're gonna see how many parts we can make. It's similar to the groups, right? So if we have 3 children and we are giving away the cookies, 18 cookies equally to each of these three children, or else they're gonna fight, right? So we're gonna count how many goes in each person. I think this is a really fun activity to do with your students. If you have actual, cookies or M&Ms, give them away. How would you do that? I think a lot of us do giving away one at a time, right? Out of 18, I can give one to Tana, one to Brianna, and one to Morgan. I still have some, so I'm gonna keep doing that until I run out of my cookies, right? And we're gonna see how many cookies in each person gets equally, right? And that becomes 18 divided by 3. And how many they have is the quotient, right? Okay. Oh, let's talk about the terminology a little bit here. I think I have that somewhere, but I just want to talk about it. So briefly to review the terminology, let me use my whiteboard. Okay. In addition, I keep repeating this again and again so you can remember. Okay, let's say you have two numbers, a plus b is equal to c. What do we call c? Base name. We call this sum. Thank you. What do we call these two numbers that are added together? Addends. Thank you. How about in subtraction? So it doesn't matter which one is added or which one is, always there. How about a minus b in subtraction? What do we call that c? The final answer? I hear something
The difference.
new. It's called the difference. And does it matter what we call a or b? Or we can mix that around?
If you mix it around, it changes it.
There we go. So we shouldn't mix them around, right? Awesome. Thank you. So what do we call a? One is minuend, the other one is subtrahend. It's confusing. Which one could be minuend?
I think the first one's minuend.
Yes, thank you. So this is minuend. Number that is subtracting is subtrahend. And again, you cannot mix them around. Okay, the first number is minuend, and next number is subtrahend. In multiplication, a times b is equal to c. What do we call that answer?
The product.
Hey, good job. Product. What do we call a or b?
Factors.
Factors. It doesn't matter which one is, multiplicand or multiplier. So rather than dividing them into, to distinguish one from the other, we're gonna say both as a factors. Awesome. How about in division? What would we call that answer? Yay, quotient. Quotient. Right? Do you think it matters which one is the names for A and B? No. No. 6 divided by 2 is not the same as 2 divided by 6. They are totally different, right? So we have to distinguish one from another. Okay. So one is divisor, the other one is dividend. Guess which one is divisor? Divisor is B because it's the divising number, right? Very good. So this is divisor. That A is the number that is divided. So it's dividend. Okay, dividend. Okay? Okay, awesome. Awesome, guys. Okay, so we quickly talk about the terminology. Okay. I want you to think about this problem. So Megan has 120 cookies. Well, 18 cookies was distribute and we can count how many there are. So 120 cookies is kind of too much. But we're gonna put 120 cookies and put that into 24 bags. So let's suppose you are Megan and you're a teacher, you have 24 students in your classroom. So you're gonna give 120 cookies equally to 24 students, and you are making 24 bags. Okay, so is it more related to you? Sounds like. And you're gonna share with your classroom students for a party, and you want to put one cookie in each bag, giving them out one by one until they're all gone. Right? That's we do most of the time at the beginning. If you don't know how to divide, how many cookies are in each bag? How would you do that? Can you work on that on your paper? Maybe it will take some time, right? Because you have 120 and you have 120 cookies and you have 24 bags to put in each. So maybe you can do one at a time, or you can think about maybe a more convenient way. I want to think about it. 120 cookies into 24 bags. And we want to find out how many cookies was in each bag, right? That's my question. So the initial thinking that you can do is like you can make 24 bags. Wow, I don't want to do that. And so agrees me. Yeah, I don't like to do that. So what is another way that we can do that? How about this way? This way. I'm just inventing this. You can invent your own way, okay? Maybe your student can think like me. I can give one cookie. So I really like table. So I'm gonna say number of cookies in a bag. And I'm gonna say the total cookies I put in. Okay. So if cookies in each bag. This is just my way, okay? If I give one cookie in each bag, I used 24 cookies, right? If I put another set of 24 cookies, I can add 24 to this one. So I have used 48 cookies. I still have a lot because my total cookies is 120, right? I can keep doing that. If I put 3 cookies, I put another 24 cookies, one in each. So I have what? Add 24 more to that, 60, 72. I still have 120. So I'm gonna put one more cookie for each bag. Then I'm gonna add this by 24 and you get 96. I still have 120. I still have some more because I only used 96. I'm gonna do another set of 24. If you add this by 24, what do we get? 120? Ooh, exactly, right? So I get to know, oh, in each bag, each 24 bags, I'm gonna put 5 cookies, right? So that's another way. Before they have, they learn 120 divided by 24. They can think about multiplication, right? But you can connect that idea, oh, this is actually same as 120 divided by 24. And you want to find how many there are. So when you're doing this, you can also think about 24 times something times that is equal to 120. So you can keep doing, multiplication until you find 120. So 24 times 1 is 24. 24 times 2 is 48. You continue this process until you reach to 120 or less than 120. times 3 is 72. 24 times 4 is 96. 24 times 5 is 120. Oh, so my quotient is 5. You can see that too using the relationship between multiplication and the division. Okay? All right. Okay, so that is set model. But when your number goes bigger, set model is kind of tedious. Okay? So it's better to think about different ways, like missing factor. Missing factor. I just showed the missing factor, right? So 120 is equal to 24 times what? That was missing factor. 24 times what? 24 and what? Those two are the factors, but what is missing there, right? That is equal to 120. So you can connect the division with multiplication there. And we talked about that terminology. So let's look at this example quickly, and then we will wrap up. Rita needs to solve 18 divided by 3. She remembers that 3 times 6 is 18. So the missing factor is 6. In other words, the fact family involves 3, 6, and 18, right? So we have talked about this when we are working on addition and subtraction. We can use the same number, right? Okay, for multiplication and division, we can do the same thing. Okay, since 3 and 18 are used in the problem, we know the missing factor is 6 in the answer. Okay, later when you move to upper grade above 5th and 6th, we can think about that missing factor as variable like x. We use the x a lot. But for younger students, we don't have to use variable. We can just put a blank or question mark. It doesn't matter. Okay. Okay, before we move on to division algorithm, I will pause here. So when you come back on Friday, we will start the division algorithm. The homework for multiplication of whole numbers is open and it's due on Friday, so please work on that. We have a quiz too? Not yet.
On Friday, I believe.
So we have a quiz. That's due on, that's gonna be due on Monday because we didn't finish the division. Okay, so only the homework for multiplication. And
So
then
no
for
quiz
reading
on Monday?
assignment is February 8th. Okay, have a good day, guys.
Yes. Yes. You have it.